Welcome to This Explainer. I am super excited to guide you through today's topic. You know, when we picture a massive structure fire, the visuals are usually just sheer, terrifying chaos, right? Massive flames, billowing smoke, blaring sirens, and what looks like absolute mayhem on the ground. But what if I told you that right in the middle of that inferno, what looks like random destruction is actually a highly scientific, meticulously orchestrated process? Well, today we're breaking down the hidden science of airflow on the Fireground.
So it brings up a really great question. If you've ever watched a fire response, your natural curiosity has probably led you to ask, why on earth do firefighters intentionally break windows and take chainsaws to cut open perfectly good roofs? I mean, to the public, it kind of looks like they're just adding to the destruction of the property. But we are going to bust that myth right now. The reality is a complete contrast to public perception. This isn't random property damage. It is a systematic, life-saving execution of physics.
Okay, let's dive into the actual definition straight from our source material. Tactical ventilation is the planned, coordinated, and systematic removal of heated air, smoke, fire gases, and other airborne contaminants from a structure, replacing them with cooler, cleaner air. So, we really shouldn't think of this as destruction, but rather as a carefully calculated release valve. By replacing all that toxic superheated air with fresh air, firefighters are essentially letting the building exhale, so they can safely get inside.
Here is our roadmap for today. We'll be covering 1. The purpose of ventilation. 2. Command and coordination. 3. The ventilation toolkit. 4. Utilizing existing openings. 5. Making the right cut. And 6. Critical safety considerations. Let's get to it.
Starting with Section 1, the purpose of ventilation. Why we ventilate? Let's look at the lethal problem of toxic smoke and heat that this tactic is actually meant to solve. According to our sources, tactical ventilation directly supports 3 absolute core incident priorities. First up is life safety. Getting rid of toxic gases and reducing heat protects both the trapped occupants and the firefighters, all while massively improving interior visibility. Second is incident stabilization. Removing that heat assists fire suppression efforts by actually controlling the fire's behavior. And third is property conservation. By venting the smoke and heat out, you limit the damage to the structure and its contents.
Moving on to Section 2, Command and Coordination, the chain of command.
The stakes here are incredibly high, because doing this incorrectly doesn't just fail to help, it actively feeds the fire. Notice the intense emphasis on danger in this quote. Unauthorized ventilation can negatively affect fire behavior and place firefighters at risk. Fire thrives on oxygen, right? So if someone randomly breaks a window or cuts a hole without a strict plan, they are introducing a massive rush of oxygen to the fire, and that can cause rapid, explosive fire growth right exactly where interior crews might be working.
Because of that extreme risk, there is a strict sequential logic to the communication chain. Step 1, literally nothing happens without the incident commander, or IC, authorizing it. Step 2, the ventilation crews must communicate their exact method, location, and timing to command. And Step 3, which is absolutely critical, the ventilation must be perfectly synchronized with the interior attack crews. The air gets released exactly when the suppression crews are inside with their hoses ready to take advantage of the improved conditions. It's like a perfectly timed dance.
All right, Section 3, the ventilation toolkit, tactical options. Let's move to the physical execution and see the specific tools and methods at a firefighter's disposal. Firefighters generally look at 2 spatial orientations for venting. First, we have horizontal ventilation. This uses doors, windows, and sidewalls. It's highly advantageous because it's fast to deploy, requires fewer personnel, and keeps crews off a potentially dangerous roof. On the flip side, we have vertical ventilation. This involves going up top, roof cuts, skylights. While it does require roof operations and structural stability checks, it is incredibly powerful. Heat rises, obviously, so opening the highest point rapidly improves interior conditions and drastically reduces the chances of a deadly flashover. And right alongside that spatial choice is the mechanical choice. Natural ventilation relies on existing wind conditions and thermal currents. You just open a door or a window and let nature do the work with minimal equipment. Conversely, mechanical ventilation brings in the heavy machinery. Firefighters use positive or negative pressure ventilation fans. This provides much greater control and really rapid smoke removal, but it requires strict control of the exhaust openings so you don't accidentally push the fire into unburned areas.
So the crucial point to remember here is this.
No single ventilation method is appropriate for every situation. Firefighters have to dynamically select their method right there on the scene. They evaluate the building construction, the fire's exact location and intensity, the current wind conditions, and safety objectives, all in a matter of seconds to formulate the right plan.
Which brings us to Section 4, utilizing existing openings, working smarter. Before the chainsaws are ever fired up to cut a new hole in a roof, a skilled crew is going to look really closely at the building itself. Our source manual brilliantly illustrates this concept. It explicitly states to utilize existing openings whenever possible. Think about it. Why cut a difficult, dangerous hole through heavy roof decking if the building already has skylights, ventilator shafts, roof monitors, or hatches? Opening these built-in features saves precious time, reduces unnecessary structural damage, requires less physical exertion, and vastly improves firefighter safety. It is all about working smarter, not harder.
Section 5. Making the right cut. Locating the fire.
Let's shift our focus to the tactical application on the roof when the exact location of the fire beneath you is basically an unknown variable. When you are walking on a roof with a fire raging somewhere below, you cannot just guess where to cut. If you guess wrong, you waste time and ruin the roof's structural integrity for literally no reason. Instead, firefighters use detection holes. These are precise, small test openings used to locate hidden fire, determine if it's extended, and assess the exact conditions beneath the roof before committing to a massive ventilation cut.
The most basic of these is the curve cut. This is simply a single plunge cut made with the width of the saw blade or chain. It is the quickest and simplest type of inspection cut. Firefighters make this tiny slit to rapidly check for smoke, heat, and fire conditions immediately below the roof surface.
Now, if the curve cut doesn't give them enough information, they upgrade to the triangle cut. This is a larger three-sided inspection opening that provides a much wider field of view. This really helps crews firmly confirm the fire's location and assess its extension to determine definitively whether a larger, full-scale ventilation opening is needed right in that specific spot.
And finally, Section 6, Critical Safety Considerations, the Master Checklist. Let's summarize the essential rules that prevent this highly choreographed operation from turning into an actual disaster. To safely pull this off, the crew must faithfully follow this systematic process. Obtain incident commander approval. Coordinate perfectly with interior suppression crews. Select the most appropriate tactical method based on the conditions. Use existing openings first to save time. Utilize detection holes to avoid guessing. And constantly monitor the structural integrity of the roof. Adhering to this exact list is what ultimately protects both the firefighters operating on a fragile roof and the victims trapped inside waiting for the air to clear. Well, we've covered a lot of ground today, and I think it completely changes how we look at a burning building. Next time you see footage of a firefighter on a roof with a chainsaw, ask yourself, are they fighting the fire or are they controlling the air? It's just incredible to realize the invisible, life-saving science of airflow management happening right in the middle of all that chaos. Thank you so much for joining me for this explainer. I really hope you found this breakdown as fascinating as I did. Keep learning, and I'll catch you next time.